Hi everyone, we are back and we are going to start to solve our exam 1 problem 2 question. So don't be shocked on this problem. We're working with CaO, which is going to be our host, and Ta2O5, which is our impurity. And we're told that CaO can go and form these 3 different types of intrinsic defects. They have activation energies of 1, 2.7, 0.13. Write out the intrinsic defects described here. So for Shocky, we're going to have null goes to a vacancy plus a vacancy, and CaO plus 2 minus 2. If we have a Frankel anion, OOX goes to vacancy and O plus an oxygen interstitial, and then CaX goes to vacancy and Ca plus cation interstitial, dot, dot. So we got all the 3 defects. What defects will dominate? It's going to be the Shocky defect because it has the activation energy of 0.13 eV. So we have our exponential minus delta HF all over KT. So our concentration of vacancies is proportional to that value. So lower activation energy, more defects will dominate. What defect will have a higher enthalpy of fusion? Self-interstitial or vacancy? Self-interstitial. Why? It's going to have a higher enthalpy of formation. Plus, it's harder to fit a self-interstitial in than to just remove a vacancy or remove an atom. Explain energetically why a crystal will have a finite amount of defects in the equilibrium structure. Well, our free energy term is this. If we do, and we know our entropy is equal to K natural log of number of microstates. So larger number of microstates, larger entropy, meaning my delta G will decrease. So if I have defects, we saw, and we actually derived this as well, that the number of microstates will increase tremendously once we create defects. So we want to always lower our free energy state, so that's why we have that answer. Defect reaction that incorporates a cation substitutional. So let's go ahead and get at it. So I'm going to go and say we're going to put Ta2O5 into CaO. We want a cation substitutional. So I'm going to put a Ta where Ca should be. So Ca is 2 plus, this is 5 plus, so we need 3 plus. For charge balance, I'm just going to do a vacancy in my Ca. It's going to be 2. So I'm going to put a 2 here. I'm going to put a 3 here. So that's going to leave me now mass balance 2 TAs. So I need 5 oxygen, oxygen X. And then below I have 5 here. Good to go. Now we need a cation interstitial. So let's go ahead. CaO, TAI, 1, 2, 3, 4, 5. Plus, let's do, for example, let's do a vacancy in Ca again. 1, 2. We'll do 5. We'll do 2. So again, 2 oxygens, so that's 5 oxygen, oxygen here. I'm charge balanced, I'm mass balanced, got the script, and then I'm going to put a 5 here. And then finally, we need an anion interstitial. CaO, oxygen interstitial here, plus TaCa. So that's going to be plus 3. I'm going to put a 2, I'm going to put a 3. So I still need 2 more oxygens. Oops. Here. So now I'm charge balanced across the top. I'm mass balanced across the script. 3 oxygens, 2 oxygens, that's 5. So Ca, I have 2, 2. That's it. Question 2. So we'll see you next time when we get to question number 3. Bye.